welcome back to ArmanisMath. Today we're going to focus on function compositions. Function composition. How do you compose functions? And I wanted you to help me out with the warm-up is here. I'm not going to spend too much time on the warm-up since we've covered this before. But probably when you watch this later, give yourself, I would probably say about 4 minutes, not more than 4 minutes for this one, okay? So I'm going to put the timer here. I'm not going to stay 4 minutes, but you just help yourself when you, again, replay this, give yourself time. A couple words on this warm-up is the need for us to extract the values that make the function undefined. So can someone tell me, looking at number 1, for example, can somebody tell me what should I not have? What is not permissible for me to have in the denominator? True. You're right. I'm trying to avoid 0, and what makes 0 is what I see some of you here in the chat, -4. So basically, you could have anything that you like except -4. So when you, as it says, find the domain. Domain at the top is okay. Domain at the bottom, we have an issue. You cannot include -4. So that is the thought for this kind of questions, a warm-up. I said we've gone over this before or something like that. So I'm going to just give you the answers and then ask if you have any questions for me on that one. And you need to spend your time, obviously, doing this after while you're watching, okay? So let me start with the first one. You should not have -4, so you, all the way from -infinity to -4, not including -4, and that's why I have parentheses. Or also -4 until you get to infinity, not including either of them. The second one is unique because the second one you could have 0. I could put 0 here I could put 0 for x, for example. I could put -1 for x, which is going to give me a square root of 0. Square root of 0 is fine. It's a 0. Since you're not dividing, it's not in the denominator, you're fine. So that's why you include it with the square bracket here. That's different from number 3, where the domain should not include 0. Because, once again, if you divide by 0, it's undefined. That's why you have a parentheses, -1, not including the 0. Log, also, you can't have a log of a negative number. We're going to have a chapter on logs and exponentials, but this should be a prior knowledge. You can't have a log of a negative number. So that's why you need to have a 0 or above. I should say like above 0, not like a tad right after the 0 for the logs. You can't have negative numbers for logs. Okay, and finally, what kind of line is number 5? Is that a vertical or horizontal line? So it's a yes, it's a horizontal line. Yep, I see it might be some delays here. That's why I was waiting for you guys. Y equals 4 is a horizontal line. And this has no restrictions on domain. Well, it shouldn't, because anything that you give it, it's going to give you y equals 4. If you said x equals 5, it's going to give you y equals 4. X equals -100, y equals 4. Here's the objective of the day. I will be able to perform operations with functions, which we already have covered. We already have done that, including composition. That's going to be the focus of the day. Okay, I'll talk briefly about operations with functions, but definitely the composition is going to take most of our discussion today. Okay, one word from the objective, either in the comments or in the live stream comment, or also in the chat, or use your whiteboard. Perform operation with and question and operations and compositions. Yep, that is exactly what we're going to do. Where do we ever use this in life? Well, I did ask you this question, if you guys remember. As you compose music, use staffs, use notes, use rest. You also can compose functions in math by combining them, and we're going to take a look at that today. If you could think of another example, you're more than welcome to share it in the chat or the comments in the video. And make sure you like and shamash the like button, subscribe. That's funny. Anyways, function. This is function operations. Operations in math are for multiplying, dividing, adding, and subtracting. So we talked about this one last time. If you have a desire to practice these, make sure that you look at last time's video. We spent a lot of time on adding, subtracting, dividing, and multiplying functions. Here's an example of that. If you guys recall, this is x to the f of x is x to the third, a cubic function, and g of x is the square root of x plus 1. And they ask you to add, subtract, multiply, and divide. Since we did spend time on this last time, I'm just going to put the answers here for you. Again, when you watch the video, please do not look at the answers prior to you attempting these problems yourself. If there's any question on this, make sure that you watch the previous video. All right. The focus today again is going to be on function composition. So this one is basically summed up in, by the way, anything with this kind of background, you know it's in your textbook, so we're not going to spend time writing this because it's already in your textbook. Function composition has two different notations. They mean the same thing for us. And this is the first one, f of g. It's f, and then there's a little circle here. There's a little open circle. It's not an O. It's not a 0. It's just a little open circle. And make sure it's open, because if it's closed, then you probably want to confuse it with multiplying. So it's a little open circle, and it's read as f of g of x. F of g of x. So in this case, that you want to combine, you want to compose functions. Another notation which is similar to this, also equally used in textbooks and math realm, is this notation as well. This is also read as f of g of x. So either one of them would serve the purpose of asking for a function composition. You're composing functions. You're putting two functions together, three functions together to come up with a product function. The composition f of g of x or f of g of x is read as f of g of x. An important note on the domain, you gotta know that when you compose functions, so for example, let's say I'm baking a cake or something, and in it I have some eggs and flour, and remember that the final product, that final good looking thing, by the way, I'm not into desserts. I like fruit, but anyways, the final product would have all these ingredients in it. So when you taste it, you're probably going to taste, obviously you're going to taste some of the ingredients, right? So what we're saying here, that's the same concept on domain. If the domain of the first function is restricted, guess what? That's going to be also restricted in the final product. So keep that in mind as you build functions. Another warning here, do not confuse f times g of x with f of g of x, because they're not the same. F with no dot here or dot means multiplication, and f of g of x is a composition. Here's our first example. Actually, we're gonna have about 10 examples here for you today, so get up for good notes today. Put an effort to be focused. So if you're distracted by anything else, please make sure that you're focused today. Okay, given f of x is 2x minus 3 and g of x is x squared, can somebody tell me what kind of function is f of x? F of x, what kind of function? That's awesome. Linear. What kind of function? What's the degree for g of x? What's the degree for g of x? It's a quadratic. What's the degree though? Antonio, you're right. It's a second degree. So it is named quadratic. The degree is highest exponent. So it says find the value of f, and you really have to read this carefully. This is f of g of 3. Meaning, and I'm going to put actually a pictogram here, perhaps it's going to help us. There is a big container here. In this case, is an f of x. That's the big container, okay? Inside of it, there is a g of x. So basically, you have to deal with what's the closest to the x first. You deal with whatever closest to the x. So I'm going to pretend this is x here. So if this is x here, f of g of x, you always start with the closest to the x. That's what you have to deal with first, closest to the x. So my operation has to deal with, I'm going to put the x in the g first. Once I'm done with that, go into the bigger container or the outer wrapping, which is a g, which is a f. So exactly the same thing here. I'm going to start with g of 3. You always start with the closest to the x. So in this case here, I'm going to plug in 3 and g. So let's see what's going to happen. I'm going to take 3 and plug it whenever I see x in my g function. So that's going to be a 3 squared, right? 3 squared. And what is a 3 squared? It's 9. So f of 9. Now we're going to take the 9. Now we're going to take the 9 and put it in the f function. So basically now I'm going to take the 9 and then I'm going to put the 9 into the f function whenever I see x. So that's 2 times how much? 2 times 9 minus 3. And how much is that? 2 times 9 minus 3, that's going to be 15. Some of you are fast typers. Good Lord. Wow. That's Jocelyn. That was pretty quick. Antonio and Ali. So this is f, once again, f of g, f of g of 3. That's how much is it? That's how much it is. F of x of 3. Okay, so once again, the idea is to get whatever closest to the x, that's the function they start with, and then put that result into the outer function. Obviously, I wanted you to keep in mind if there's a restriction domain, that restriction carries along also with the function. In this case, they didn't ask about that, but obviously in here, there's no restriction on domains, right? Could have anything that you'd like. So first step, I plug in f of a g, I should say, start with the g. And then the second step, I start with take whatever I got, put that into the outer function, which in this case is f function. More on this coming. This one is a little bit interesting. Armani, this is the same. Not exactly the same. So let's pay attention to what's going on here. I see g of f of 3. Oh, that's a little bit different. Of course it is. Because now the outer container is the g of whatever thing, right? And the inner container is f. So you gotta basically deal with this first and then do the outer wrapping. So step 1, I'm going to do the g of f of 3. So take 3 and plug it into the f function. Every x would be replaced with 3. And how much would that be? 2 times what? Hello. Thank you. 2 times 3 minus 3. That's a 6 minus 3. How much is that? 3. That's a 3. Yeah. And that is a 3. Chach times shalosh. That's in Hebrew, shalosh. 2. I do the g function. G of whatever I got there, right? G of 3. Alright, so I'm going to go and put 3 into my g function. So that's going to be 3 squared. And how much is that? Yep. Très bien. That is true. 9. 9 is the answer. 9 is the final answer. By the way, this is a g here. 9 is the final answer for that question. Thumbs up if you're doing good. Thumbs up if you're doing good. We're just gonna kind of spice it up just a little bit now. Okay, I'm looking for more responses, more feedback. Good. All right. So let's move on. What if I have this function here? Can somebody tell me what kind of function I'm looking at? F of x. What kind of function is f of x? Do that while I'm getting a sip of tea. Would you like some coffee? No, I like tea. Exponential. Yes, and we will spend time on exponential. Yes. And logarithm. Somebody was asking earlier. Logarithm and exponential go hand in hand. So anyways, this is 2 to the x. Actually, I was spending time with my daughter today, showing her some exponentials and stuff. So this is f of x is 2 to the x power, and what they wanted me to do. Which one should I start with? Can somebody tell me which function do they need me to start with? Yes, the J. I'm gonna start with the G of 4. Okay, G of 4. If I put 4 into the G, blah 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 blah. Oh, here we go. So that's gonna be 7 minus 4. And how much is that, you guys? Again, 3. Okay, and then they wanted me to take that and put that into the f function, f of 3. Okay, so it's 2 to what? What? 2 to the what? To what? Yep, thank you. 2 to the 3rd. 2 to the 3rd. And how much is 2 to the 3rd? 2 to the 3rd. That's 8. That is true. So the final product is 8. To that, I'm going to actually highlight because that's the final product. 8 is the final product for this one. Let me just take it one step further. They didn't ask for this, but we always go the extra mile. Remember, if you do what you're asked to do, you just average. That's normal. That's what you're supposed to do. You always go the extra mile. You always make your work neater. You always present yourself in at your best. Okay, not less than your best. So, anyways, what if they wanted me? They didn't want me, but what if I wanted to? For example, say I wanted G of f of let's say G of f of 2. Let's try this one. Try this one here for a second. Okay, try this one. G of f of 2. Whiteboards would be awesome for this, since I want to see some mistakes. I want to see some good answers. I want to definitely see your thought process. So we also are probably going to use some other software to help us with the whiteboard. Nearpod is one of them. So I see a couple of whiteboards at the moment. Let me try to increase so I can see better. What's it? Okay, I see that, and I see that. Yep, I see Taiva, and I see Kumar. Yep, looking good there. The whiteboard looking good with the answers. Okay. So anybody else here in the chat? Did you guys work this out? A couple are showing up again. I see, yep, I see Callie. Laura, if you could bring the whiteboard just a little bit closer. Yep, I see that, Antonio. All right, so do not wait for people to put in the answers, you guys. You also do that, okay? The math is a game that you have to participate in. Gavin, I just saw that, Gavin. Good job. Looks like Jocelyn is also coming up here. Yep, that's very neat, Jocelyn. I love that work. Very neat. Okay, so I'm going to take 2 and put it in F. 2F, that's going to give me basically a 2 to the second power, which is 4. And then from there, I'm going to say G of 4. And G of 4 would be 7 minus 4. The final answer should be 3. Okay. All right, what if I have this here? I have G of F of 4. Can we try this? G of F of 4. So I'm going to put 4 here. No, that's not what I'm going to do. Where do you think I'm going to start? With the F or with the G? Exactly, I'm going to start with the F. So what's 2 to the 4th? Ay, ay, ay. What's 2 to the 4th? Somebody help me out here. So we said initially you do F of 4, which will be 2 to the 4, 16. And step 2, I'm going to take the 16 and put that into the G. G of 16 would be 16, 7 minus 16. Which would give me Jordan. Okay, I see that, Jordan. Negative 9. Negative 9. All right. Let's move up a little bit here in the food chain supply. Here we go. It says here you can use algebraic expression as well as numbers as inputs into functions. They're telling you you're not stuck with just single number like f of g of 2, g of f of 5. You're not stuck to that. You think bigger. You could put any you could put any number, and the word any number is a variable, which is x. You could use x also as part of your composition, basically. So in this example, I have 2 functions here. Can somebody tell me what's f of x? What kind of f of x? What kind of function is that? Quadratic, thank you. G of x, does anybody know? If you had me last year, you probably would know. But G of x is called something. And I see a pause. I don't blame you. It's called rational. Okay, rational functions. Rational functions. Anyways, what they wanted us to do here is to take the f of x, not f of 2, not f of 3, f of x itself, and put that into the g function. So once again, the graph that I showed you initially, that little demonstration pictogram here. So the g of x is the bigger item, and inside of it you actually put f of x. And this time you're not going to put number for x. You're actually going to put f of x by itself. So here, what they wanted you to do is take f of x, and I'm going to call it a blob. Okay, I'm gonna just, that's just me. I'm gonna name it as a blob. So they wanted the f of x, which is this blob, and they said you're gonna take this blob and put it whenever you see x. Well, it shows up more than once, right? So you're gonna put it here and you put it here. That's where you replace the blob with. Okay, so don't forget that. They want you to take this whole entire thing, a box, and put it whenever you see an X. That's number one. Number two, they wanted you to pay attention to the domain. And they're right about what they're saying here. Because here, for example, there is no restrictions, right? This is quadratic. We talked about that earlier. But this we have a problem. What do you think the value that I have to exclude from the domain here? What value should be excluded? What value should not be permitted? That's very true. If I put 1, that's 1 minus 1, that's going to be a 0. Well, that's not a good thing, Armani. That's not a good thing, right? You don't want that. This is not mustache. This is a sad face. This is not mustache, it's a sad face, okay? Not scary, it's a sad face. So you don't want that. So I have to exclude 1 from the domain. So keep that in mind, okay? By the way, while we're at it, I'm also going to spider review. Spider review means I'm going back to whatever I taught before. This is not good, right? We talked about that. But is this also informative? Does this tell me something? Is this beneficial in any way? Come on. Help me out here. Come on. More than that. I wanted something more than that. Yes, I got undefined, but we said it's not good because it's undefined. I have to exclude the value, but it's also the flip side of it is something that tells me something. Come on. Yeah, but there is something that is beneficial when this happens. It tells me something. Well, let me bring it a little bit closer then. That means we need to watch the prior videos, by the way. Does anybody remember what happens when you have a 0 in the denominator? Can anybody think of invisible lines we talked about? Ah! Come on! Now I see multiple users are typing. Yes! The asymptotes! It's not a bad word. The asymptotes. It tells you there's an asymptote. By the way, does it say what kind of asymptote? Does it say what kind of asymptote we have? Is this vertical? Is this horizontal? What's going on? When you have 0 at the bottom here, denominator, vertical or horizontal? Come on. Yes, it's vertical. Whatever makes the denominator 0 is going to be a vertical asymptote. So I'm expecting to see a vertical asymptote. Vertical asymptote at -1. I'm sorry, at 1, because x1 is excluded. So you should have a vertical asymptote at 1. Come on, you guys. That was a couple lessons ago. Come on. Vertical asymptote at 1. X equals 1. So, okay, because again we are same here, so let's actually also review. How about I'm just curious, horizontal asymptote. Does anybody know? How would you get this? Horizontal asymptote. So vertical, I know whatever makes the denominator 0, and I know in this case it's going to be at 1. There's a dot like this. But what about horizontal asymptote? Ooh, you guys need to review that video. Yeah, vertical asymptote, horizontal asymptote. Or if you're taking good notes in class, flip through the notes. You should see something. And it looks like this. Hello? Are you looking at your notes? Are you taking notes? Ay, ay, ay. You just guys, you just like watching videos. Take notes, you guys. Yeah, I know that. Okay, I'm gonna give you a few seconds. Look at your notes and tell me what's going on here. What kind? What kind? What kind of horizontal asymptote we're looking at here? Yellow. Yellow. Okay, Laura is saying y equals 0, and I'm not sure which case he used. Remember, we have 3 cases. When the top is less than, come on, you guys, numerator is less than the denominator, y has to equal to 0. And this one with numerator equals denominator, the degree of the numerator equals the degree of the denominator, then you look at the numbers, right? Look at the coefficient. And when the degree at the numerator is greater than the denominator, there's no horizontal asymptote. You guys. Hello. So which one do you think I'm going to pick out of these 3? Which one is applicable here? Case number 1, 2, or 3? Yep, it's equal to. And if it's equal to, you really have to pay close attention here, because the what it says, you're going to look at the coefficient. The coefficient at the top is 1, right? And the coefficient at the bottom is -1. So pay attention. There's a negative here. See that? Negative? Divide by -1, which will give you a -1. Come on, you guys. That took us on a interesting review here. Back to what we need to do over here. This was a quick review, but now we're gonna do what we are assigned to do. And this one is f of g of x. So pay attention now. I'm gonna take this box and again put it wherever there is an x. So basically what I'm saying here is I have a g of the entire function, which is this f thing. G of this blob. So I'm going to go to the g and plug into or substitute x squared minus 1 whenever I see x. So it will be x squared minus 1 divided by 1 minus, and use parentheses because it's going to help you a lot, particularly if there's some negatives. And if I'm careful about this, we'll find myself looking at x squared minus 1 at the top divided by 1 minus x squared plus 1. And if I'm careful again, I will end up with it being like this. 2 minus x squared. You also could say negative x squared plus 2. Both are fine. So that's going to be your composed function. So basically composing 2 functions in this case using just the function itself. You're not using any value. And this again, this is powerful because you're not limited to one single value. So this here that you see is actually g of f of x. That's going to be the last product that we looked at. I do want you to pay attention again, because the restriction that we started with a domain, we should not include 1, if you guys remember that, right? Also, the final product has its own restriction in the domain. So you do not want this to be 0, right? So how do you make sure what value makes this 0 so you can exclude it? Well, you could set it up to 0 and solve. So you could say I have to exclude whatever makes this denominator 0, and whatever makes it 0 is going to be solved here. So you're going to say 2 minus x squared equals 0. And then you're going to, you could add x to both sides, so x squared, or you could subtract the x's. You could subtract the 2's. It's easier to add the x squared to both sides. So x squared equals 2. X equals plus or minus square root of 2. So you also have to exclude these, by the way. So not just the one that at the top, but also you have to exclude plus or minus square root of 2 as well. Okay. Oops. So in here, I know that I have g of 1 is undefined. I really have to take care of that. Also, I have I cannot include plus or minus negative 2, square of 2. So keep that in mind as you're solving problems like that. You look at the original function. Make sure that you deal with the original function first for the domain, and then also the final product. If it does have additional restrictions, that also you need to account for. Okay, how about this one here? This one says given f of x is 3x minus 4 and g of x is square root of 2, pausing, plus 2. Square root of x plus 2, I should say. Write each composition. So the first one is g of f of x. Somebody help me out here. What's the blob that I have to highlight? What's the blob I'm highlighting here? Stay with me, guys. Stay with me, okay? Stay with me. Actually, yes, I'm going to have to take the blob, which is f of x. So my blob in this case is f of x. And that guy is what I have to put into any time I have to see an x on the other function. I just have to put it there. So at g of f of x, meaning I have to put 3x minus 4 whenever I see x into the other function. So that's the square root of 3x minus 4. Pay attention when you do the square roots, you do not include that 2 on the outside, because that is not part of the square root. Could this be simplified? What do you think? Can I touch the negative 4 with the 2? Can I simplify this? Is that possible? No, you cannot, because this part is under the square root. You're not. The 2 does not belong to the square root. So you can't touch it. Do I see any domain restrictions? Oh, good. Let me go back here. Do I see any restrictions on domain? Does anybody know if there's any restrictions on domain? Go back here. Guys, come on. Press on. Don't want to lose you here, okay? Focus. This thing is gonna intensify just a little bit more. A little bit more spices. Yes, there are some limitations. In g of x, there are some limitations in terms of domain. I can't have what? Because remember, domain, we wanted all real numbers, right? So what is excluded in this function here, in the g function? What do you think is excluded? Exactly, imagine numbers. So whatever is going to make this guy negative, that's what I'm going to exclude. And in our case, it's going to be anything that is below 0. So anything below 0 should not be permitted. And for the original one, okay? For the original one, or whatever we started with, anything that is below 0 should not be permitted. Now, what about the final product, the 3x minus 4? Well, you also have to take the 3x minus 4 itself and solve that, right? You're going to take this dude and solve it. So, meaning put that equal to 0 and see what's the restrictions. So I'm going to do it here. 3x minus 4 equals 0. Add 4 to both sides. 3x equals 4. Subtract, divide by 3. X equals 4/3. Anything that is less than 4/3, that is not permissible. You should exclude that, because once you have 4/3, then you're going to have yourself 0, but anything below that is going to give you a negative number under this composed final product. So remember, the initial had anything below 0, but also the composed function has to be greater than 4/3. So if that is true, I'm going to follow the most restrictive, which is, again, in this case it was the final product, which was the most restrictive. So I can't even have 0 in this case, because in this case 0 would make it a negative number. So I have to go a little bit higher to accommodate for the composed function. Okay, oops. Now let's see f of g of x. F of g of x. This is interesting because now this is the flip side of it. 4/3. Somebody was asking how did I get 4/3. Okay, so I took what's under the square root, because remember I needed something here. I'm reviewing because somebody was asking how did you get the 4/3. I'm taking what's ever here, the radicand, what's under the square root, and I'm equating that to 0 to solve for it and trying to avoid having negative numbers here. So what I did is 3x minus 4, and you could watch the video obviously one more time, equal 0, and then you add 4, and then you divide by 3. When you replay this video, you might want to pause a little bit on that item. Gavin, did that help? Okay, so now let's move on to this one here. This says f of g of x. Okay, so now the blob, you're welcome. The blob now is actually going to be, what's going to be my blob? Somebody tell me, what's the blob? The g. Now you really have to focus on this g. The whole thing, by the way, the whole thing is a g. So now you're going to take the g and then plug it whenever you see x. Simple as that. So I have f of g of x, which to me will mean I have 3. Actually, let me spell it out for you. It's easier that way. So f of what? F of the blob, which is square root of x plus 2. That means I'm going to go here and go 3 times the blob, square root of x, plus 2. Be careful, by the way, when you do these, especially with the radical, not to include the 2. And in this case, I'm just going to have to multiply. 3 times x, that's 3 square root of x. 3 times 2, how much is that? Three times 2 is 6, that's correct, minus the 4, and this is 3 square root of x plus 2. That's going to be the final product for this dude here. Now, if this is the final product, let me see, because they did ask me about the domain, so let me see what kind of domain I could have, what kind of domain I'm permitted to have. At the beginning here, look at the original equation first, original function. What's restricted here? Square root of, we talked about this one, remember? Anything that is below 0 is not permitted, so keep that in mind. Nothing below 0 here for the original, or the initial function. What do you think is going to be here? Is this going to change? If you want to end up with all real numbers as domain, is this going to change? Are the restriction going to change? In what way would that change, though? If you're trying to avoid having a negative here, isn't this the same as having the negative here? Because all what you care about, not the 3, well, I mean the 3, whatever the 3 is, that's just going to be a number times whatever you get here. So your main restriction is going to be, again, back to this initial function. You want to see what makes this guy and imaginary numbers, right? And in this case, it's going to be anything that is below 0. So you want to restrict your domain to be above 0. Above 0 is where you want to be. Okay, gotta pick up the pace here. This function here is, I'm gonna spend a couple minutes here. This function is exponential. This function is a square root. And I'm going to give you maybe a minute for the first one. So f of g of x, what do you think? F of g of x, they're not asking for numbers, just asking for the function itself. Which one are you going to start with again? For letter A, which one are you going to start with? The g, that's the closest to the x, right? The closest to the x, that's the g. So basically you're going to take the g box, and then you're going to put that into, substitute that into your, it's going to look interesting. So I wanted to see if you guys can do it on your whiteboard or something. I'm not going to just finish this for you, but tell me. It's really, the look of it is interesting. So whoever's done, can you share that with me or with us? Remember, in this class, you could share incorrect answers. You could share your thoughts. This is a safe environment. You just share. It doesn't have to be the correct answers. So, obviously, if it's not correct, it tells me that I need to show things or to reteach or teach a different way. So it's beneficial for you to show me what you've got. Okay, I see a couple whiteboards here. Okay. I see that. Okay, good. So now I will just basically take this blob and put it here. It's going to look funny. It's going to look like 2 raised to, that's interesting, x plus 1. Yep, that's what it's going to look like. How about g of f of x? Well, this one is reverse. You're going to take the square root, x to the second power, stick that into this one here. I think that's what Jordan has done. You're going to take the square root and put that whenever you see x. So this is 2 to the x. That's funny. Plus 1. Yeah, it's kind of awkward looking thing, but that's what we have. Okay, that's going to be what it looks like. And finally, this is the idea of decomposing. What? So you composed functions. We were composing functions, putting them together. Is there a way for us to decompose? This is almost like the idea of reverse engineering. Some companies take the product of some or their own company and they do a reverse engineering. They actually do the project backwards. So for example, let's say that they manufacture a car and now they want to modify something in the car. So they go backwards in the design. It's decomposing. Decomposing is an interesting idea. So you take basically you take the composed function back to its parts, to its ingredients, if you may. So in this case, let's say h of x is the finished product, which has f of g of x, which means you have g of x here. So if this is h of x, which has 2 functions, by the way, this is a composite of 2 functions. What do you think could be the g? What do you think could be the x? So here's my thought. G would probably be something like here and like this to me. G would be something like x squared plus 5. And an f of x would be something like square root of x. Because if I wanted now f of g of x, I'm going to take, once again, the g, the blob, right? The blob, and put that whenever I see x. So that's going to be the square root of x squared plus 5. So basically, I worked the problem backwards. I decomposed it to its components. And by the way, some of these answers may vary. So it just depends on how you look at things. So you could come up with different answers to match decomposing of a function. This is the last thing that I'm going to share with you today. And with this, we're going to conclude. Make sure that we keep up the hope and we are helping each other during this pandemic. We're thankful that we have a merciful God who takes care of all of us. Okay, guys, be blessed wherever you're at, and this should conclude our lesson today.